Hello everyone, my name is Qi. I'm a PhD student in epidemiology at Emory-Rollins School of Public Health. This study addresses the challenge of bias adjustment for misclassification when using sparse validation data. In practice, to account for misclassification using probabilistic bias analysis, beta distributions are often assigned to bias parameters such as positive and negative predictive values for simplicity, PPV, and NPV, using data from an internal validation substudy. Due to small sample sizes of validation substudies, zero-cell frequencies can occur. The objective of this study is to optimize strategies that mitigate sparse data problems when adjusting bias for misclassified binary exposure by assigning prior distributions to PPV and NPV. To achieve this objective, based on simulated cohort studies and internal validation substudies, we evaluated 5 approaches, including using a conventional method without a prior and using different Bayesian priors and continuity corrections for assigning beta distributions to PPV and NPV that were estimated from an internal validation substudy. We evaluated performance by measuring coverage probability, bias, and mean squared error. Results showed for sparse validation data, methods using a prior or continuity correction all had better coverage and a lower mean squared error than the conventional method, with the uniform prior yielding the best performance. That was when both alpha and beta of the prior distribution equal to 1. Considering limitations, we didn't evaluate all possible simulations, as there are an infinite number of possibilities in terms of bias adjustment factors, but we have provided our simulation code so that researchers can adapt it to other validation substudies. To conclude, if sparse data are expected in validation substudies, using a uniform prior for the beta distributions of bias parameters will improve the validity of the bias adjustment measures. These findings will inform the bias analysis plan to account for misclassification using validation studies, particularly when the zero-cell problem is expected in validation data.